The last thing to look at is the application of the sequence and acknowledgement numbers as we send this data. What we are seeing here is a sender that is connecting to the receiver via telnet. We see that our destination port is 23, meaning that this receiver is a telnet server. My source port is 1028, so anytime my receiver sends data back to the sender, it is obviously going to have to be received on TCP port 128 to be sent to the telnet client. When the sender establishes the three-way handshake, it establishes its initial sequence number, in this case number 10. Notice that it will send number 10 for all information with ACK number 1. The receiver will then acknowledge the original sequence number by incrementing it by 1 and sending back its own sequence number 1 here. The destination port is now 1028 from source port 23. Now take a look at the sequence number due to the number of bytes of data that are being sent. Here is ACK number 11, and here is 250 bytes of data that are being sent. Notice the sequence number. I must sequence all the way up to 260. When all 260 bytes have been received, the acknowledgement number is going to be 261. This indicates that all of this data has actually been sent. So you can see the difference, 10 bytes of data, and the acknowledgement number becomes 11. Notice the sequence number now. It bumps it up by 250, so my sequence number is now 260, and it must be acknowledged with 261. The receiver is not actually sending any data, and that's why its sequence number is staying relatively small, by only incrementing one time because it is not sending much data back. This is an example of the sequence and acknowledgement numbers that are used in TCP.